Right, everybody, today we have on the bench an ECU for Audi Q7 3-liter V6 TDI. It's an EDC17CP04 with 02810158868 part number. So before we go any further, let me introduce to the AI Council. Is the AI Council ready for this live session? Say hello to the viewers. Good. So now let's see what we have here. The council is a bit quiet, or they did not hear me. Is everybody ready for the testing this Audi ECU?
Council's locked in and the bench is live. Hello to all you gearheads watching. Let's pop the hood on this ED17 and see if it's the real culprit behind that hard start.
Ready when you are, John. First step is confirming identity. Let's verify that part number 02810158868 and the EDC17CP04 marking on the case before we touch anything.
Just did some upgrades in the AI Council. So let's go on the bench and let's see what we have here. So we have this EDC. There are some watermarks, as you can see here and here and here. How often are these Q7 ECUs get water damaged? Council is not answering to me today. They're a bit cheeky. How often it's this problem with water damage on the Q7s?
Water intrusion on Q7 ECUs is a real pattern. They live low in the plenum, where cal drains clog and rain finds them. So corroded connector pins and green crust are common finds.
Water ingress is a classic Q7 nightmare because the ECU sits right in the plenum chamber where leaves clog the drains and turn it into a bathtub. We need to check those seals before we even think about powering it up.
Pretty common on Q7s. Water ingress can creep into ECU areas and connectors, causing hard starts or limp power. But we still prove it with inspection, not folklore.
Water damage is a frequent Q7 ECU killer. Always inspect the plenum drains and case first before blaming software.
Thank you very much, Council. Let's go back. We did open. We take all the screws out. Now let me find a flat screwdriver. Let's find a flat screwdriver. No, it's not here. It's supposed to be here. Yeah, we have our new ECU. We're gonna put the ECU on this hot plate, so I think it's quite good. I used it before, but I get a new one as I was in need for another one, and it's an 800 watts one, so we're gonna test it today. It's brand new. We'll see how it goes and how it will heat this ECU, so the adhesive will allow us to open it. Now let me find a screwdriver. I'm supposed to be ready, isn't it? Why? Somebody nicked my screwdriver. Maybe the dog. Ah, there you go. No, that's not the right one. But anyway, let's work with what we have here. A second. Need to find the proper screwdriver. Yeah, that's it. So we did find a proper screwdriver. So this ECU has been opened before, so this for the top will come off easily. Okay, so we get the top off. Now let's do an inspection and let's see what we will find. So the connectors first. Let's look into the connectors. As you can see, I can't see no water damage there. In this connector side, no water damage here either. Good. Let's go back on the actual board and let's start from one corner to another. So bottom right, let's look. Nothing obvious so far. Nothing here. Nothing here. Nothing here. So this is the main processor where all the data is, the immobilizer, the EEPROM, the flash and everything. Nothing obvious here. Nothing. Oh, that's something a bit strange about here. That dust should not be there. Let's go. The customer said that he found something moving inside the ECU case, so I'm wondering what it is. I did not find anything moved. There's still nothing there anymore. So most likely when they open it, that component or whatever it was, it must be a component because it can't be something else going inside. Nothing obvious. Nothing. Nothing. That's weird. I think I will get the microscope for a bit. Let's look under the microscope. Let's move some things around. And let's see under the microscope. What is truly there? Good. Now we're able to see. Let's focus it a bit better. Yeah, that's way better. So we are here. No. Where do we find that dust? Over there. What is there? Looks like a bit of water ingress on the resistors. Okay, let's see what else we can inspect. So far nothing apart those two things. A little bit further inspection. Really interesting to see if it's a component missing somewhere. Let me get a tweezer. Let's see if this will go away. Well, there's definitely some sort of dust or something. Can't see anything. The customer complained about the injector side is not working properly, and we are around the injectors. We're around the injector. This is the whole thing here. The whole thing down. It's related to the injection side. Some resistors here. Still can't see it. Let's ask the council. So, where should we look inside the ECU to see if the injectors drivers are okay or not?
Good call. Opening it lets us inspect the injector driver stage and solder joints for cracks or burnt traces. Show me the board under the microscope.
That Bosch EDC17CP04 is a tough cookie, but throwing new injectors and a pump at this Q7 without checking the ECU's driver ICs first is just expensive guessing. Let's get this case open and inspect those piezo driver traces under the scope.
Good shout, but let's call them injector correction adaptation values, not vectors. Check evidence first. ID backup, then compare data without blind rights.
Panels aligned. Open her up and scope those driver traces before we chase ghosts in the maps. Let's see what the board's actually saying.
So let's get back to the board. It's very hard to find anything on the board, so I'm just gonna try to look a little bit further and use whatever we have at our disposal. Still nothing there. Can't see no clear problem. Need to get some new lights for the microscope. Nothing. Nothing. That's very weird. That's quite stable there. Because usually when you see something like this, when you have like an intermittent injector problem and not starting, you should see some problems. It's getting so hot today. Let's measure some values then. Let's add not a scene, let's add a source. And let's add a multimeter on the scene. Let's go 500. Let's crop the picture. 650, 690, 720, 20, 30. So add the digital multimeter. Okay, and another 20 here. Perfect. And now we have our scope there. We have our digital multimeter there. Good. Let's see what we're gonna do. What should we scope first? Let's move the microscope away. Let's check a bit of resistance. Okay, it's beeping. That's good. No short. No short. No short. No short. Yeah, the middle it's shorting because it's connected to the top. I'm interested in this. This looks like something was here. I think my suggestion will be to clean these pads, these resistors, and solder them back, because I can't see no other obvious marks. No burn tracks. Or we should open it up completely, but I will better clean it first. So let's do a bit of cleaning in that area with some isopropylic alcohol. And then add some flux. Let's add some flux. Perfect. Get some proper soldering. Just wait a bit. That's it. That's it. That's it. That's it. Let's go to this capacitor as well. I will go and solder all the big ones as well. These are injectors, the output stages, and grounds and output stages. When you don't see no obvious mark, You just do the obvious things that usually failed, because there may be cracks that we are unable to see them properly. Not even with the microscope. Let's ask the council if it's okay, what they say, if it's good to resolder. It's good to resolder the output stages soldering points of the injectors.
Reflowing injector driver joints can help if you actually see cracked solder. But blind reflow on a good ECU risks lifting pads and masking the real fault. Prove it first with a scope.
Whoa, hold those irons, chat. Reflowing solder without testing first is just guessing, especially since this Bosch EDC17CP04 uses high-voltage piezo injectors that require precise driver diagnostics before we heat anything up.
Good idea only if the evidence points there. Cracked solder on injector drivers can cause misfire or no drive, but blind reflow can turn a suspected ECU into a damaged ECU.
Verdict, solid advice, lads. Scope the drivers before you touch the iron, or we're just swapping guesses for lifted pads.
There are no pads to lift, as the unit was already had some how do you call, some dust, some electric dust around the driver, so that's why I decided to solder them.
That corrosion around the driver is a real clue. It points to a power path or moisture ingress problem, not just a coincidence. Photograph it on the microscope before you touch it.
Soldering is definitely the safest bet when those delicate pads are compromised by corrosive electric dust or moisture intrusion under the Bosch case. Let's get a close-up on the microscope camera to see if that driver's logic gate survived.
That electric dust is usually corrosion or burnt residue, and soldering test points can be safer than fighting weak pads. We document it so nobody mistakes our repair access for the original fault.
Corrosion around the driver screams moisture history, not random dust. Let's microscope it before soldering risks the gates.
So the soldering, it's a good idea eventually. What I realize with this AI system, if you don't give the full context, they will not guess blind and they will play safe. And when I say they will play safe, what I mean by that is basically they will not vouch for any kind of repair unless they see the obvious thing that we people will see it too. So just a few ones left on this side. And then I'll come. I may try to open the other side as well, to be honest. That dust, that electric dust, has to come from somewhere, and I can't see no obvious point on this side of the board. Sorry that sometimes I'm not fully prepared for doing the live. It's just the fact that I'm working as a mobile electrician as well, so I'm running up and down, up and down. My life is always on a run. So where is this? So we have this beauty. We're gonna put it to heat up. Let me put it on. Good. Turn it on. let's set it for, it's about 30 degrees, 31 degrees inside. I'm gonna set it for about 350, 340. Good. Perfect. I'm gonna put the ECU on it. I don't know if I can show it. So it looks like this. It's 350 volts. So you just leave it on the hot plate until for about 5 to 10 minutes. I'll see it in a minute anyway. And then that glue comes off way easier, and we should be able to get it off easier than before. Now let me look for some gloves, because I'm gonna have a problem to put my hand on it. Next time I'm gonna put everything prepared. Some gloves. I have some quite tough gloves. The magic glove. It's for the left hand. And we can use a towel as well. So we don't damage the bench. Good. So while we wait, let's see what else we have to do. It's already smoke coming out of it. I'm gonna need 2 screwdrivers. It's melting. So what do you think it can be in the end with intermittent starting and the fact that injectors were not activated? As far as the customer told us, the injectors are not activating properly. We're gonna open the ECU fully, so we don't know yet what's on the other side.
If injectors aren't being commanded, I'd chase the driver stage and power supply to the ECU before blaming logic. The injector output section on the EDC17 is a prime suspect.
Before we blame this Bosch EDC17CP04, remember that new injectors must be coded correctly, or the driver stage won't fire them. Let's inspect the board under the microscope for cracked solder joints before we power it up.
Intermittent no injector firing could be ECU power ground, crank cam sync, immobilizer or driver stage trouble, not just bad ECU. Opening it is useful, but evidence first, surgery second.
Power or driver stage likely, but let's crack it open under the scope before we write anything off.
We will open it as soon as possible. Good. So it's about 304 degrees. We have a thermal camera that we can look. Let's see what's the temperature over there. So it's open. It looks like it's discharged. Oh. That looks okay. I'm gonna start it from this side. Slowly. Do not push it too hard because you risk bending it. And they are very sensitive boards. Okay, slowly. Take your time when you're gonna open this kind of ECUs because they're very expensive and you can't find really a lot of them available. So taking your time will minimize the risk you're gonna bend the board. Good, that's okay. It's already started to come off easily. Both sides, good. Good. Slowly. Slowly. Good. Slowly. Slowly. Better slowly than sorry. Good. We leave this side a little bit more. That's good. Put a screwdriver under. A screwdriver. We're gonna put a tweezer under. We're gonna go slowly, slowly, slowly. Good. You hear that pop? That means the silicone almost came off. Gonna put like one there. And good. Good. I think I can take my glove off. That's fine. That's it. Yay! So I have it out. Perfect. No bend, no broken component. That's perfect. Now let's see the truth on this side. Oh! Look at that! Look at that, where that dust came from. And we have some watermarks there and there and there. Yes, so it's not coming from the first. Oh, look at that! That's even worse. Look at this here and here. So the water, and this is the side with the high voltage injectors. So let's see anywhere else. Yeah, over here a lot of water over there. Look at that, as much water. How much more? How? Where it was the fault all the time. Look, it went even here, as you can see. Oh my, yeah. We are 100% sure that is the problem. Let's send the council the picture, and we can send the council the picture as well. Q7 water, and let's see what the council says. I need to get used with the council production control panel. I built it in the last couple of days, and I built it so complicated that even myself I have problems to use it, to be honest. Research bench fed. Okay, so we're gonna go to pictures, screenshots, Q7 water. Good. Q7 close to the analyze it. Good. And now let's go on the air council and let's see what they have to say.
That's a classic Q7 water ingress scar. I see the injector driver area with green-white corrosion tracks and mineral deposits around the IC legs, meaning electrolytic damage, not just surface dirt. Those copper pads have started to etch away.
That's corrosion and white residue around the two Epicos Q1730 injector driver transistors. Classic water ingress damage near the drivers.
That is severe corrosion, bridging the terminals of those Epicos Q1730 inductors in the injector driver circuit. That crusty green and white oxidation is definitely a conductive path from water ingress, which explains the hard starting.
That's moisture and whitish corrosion residue creeping along the board right beside the Epicos Q1730 power inductors, near the injector driver stage. A classic leak path.
Those are Epicos Q1730-08 14C injector driver inductors, and the nearby white-green crust is definite water residue and corrosion. I'd call this a real contamination hit, not normal flux.
So we got the council opinion, which I agree completely, 100%. And now we should clean as much as we can. And we found the broken component. Let's scroll down. Let's move on the microscope. And let's see the broken component. There you go. We have a broken component, but we don't know what it is. Yeah, it was something there. Looks like a cap or something. I need to get a better microscope, but something was definitely there. Exactly, so the broken components is exactly here. So most likely that was the one dancing inside the ECU. So now let's do a bit of cleaning. I will say a bit of isopropylic alcohol, and then I think this ECU will need to find out exactly what component is there. I wish I had more hands, to be honest. It's already looking better, isn't it? But I think this ECU needs to go to the ultrasonic cleaner as well. Because the ultrasonic cleaner will be able to reach this side, under this side, so we don't need to remove all the components in order for them to be clean. So wherever the water reached, the ultrasonic will reach too. Look, we have spaces where we can't literally reach. Or worst case scenario, you know what we're gonna do? We're gonna unsolder all the components. But I will try first with the ultrasonic cleaner. But worst case scenario, we can do that. So let's try different types of brushes. Let's try different kind of brushes. One second. Let's clean it more. Yes, definitely that was the dancing component right here. Anybody knows what that component is? Just leave a comment. Must be a capacitor, it can't be something else. I'm sure the capacitor is one of stabilizing capacitors. Oh, this water damage is, look at this, this one is way worse than what we have. Yeah, and it's exactly on the I don't know exactly the English word, but is the these two components, they raise the voltage for the injectors to open. Some sort of transformers, small transformers, and it makes sense why the injectors did not open. Okay, so let's clean properly there. Now we're gonna put it under the ultrasonic, but I'm gonna do as much cleaning as I can here, and the ultrasonic will do the rest. But remember, if you don't see water, if you don't see water signs on this side, that doesn't mean it's not water damage. A second, because my phone keeps ringing. Good. So if you don't see any water marks on this side, that doesn't mean the other side does not have water inside. So it's better for you to open it completely, so you inspect this side as well, because as far as we can see, we find a lot of corrosion around the injector drivers. Good. Let's see what. Yeah, most likely we'll need to put it under the ultrasonic. Whatever it's inside there, we will not be able to reach it. Let's see if there was any other sides. The rest of the board looks okay. Looks okay. Those are the fuses as well. These ones, the output fuses for the injectors, they look okay. We have here a little bit. It's a little bit of water here as well. And now it dries instantly. It's about 30 degrees inside. And if I put the vent on, it will blow the mic. And you will hear the fan blowing in the microphone, which I don't want. So let's ask the council if we're gonna put it into the ultrasonic cleaner, it would be a good idea. Okay, council, I found the water, but I can't access all the places to clean it. I think the next place this ECU is going, it will be into the ultrasonic cleaner. Is that a good idea?
Whoa, ultrasonic on a live EDC17? Only after you've got a verified full backup off it, John, because moisture plus corroded traces can kill a marginal board.
Using an ultrasonic cleaner is highly effective for getting under those tight BGA chips. but we must use pure isopropyl alcohol or specialized electronics chemistry, not water, and dry it completely afterward.
Ultrasonic can help only after power is off and data is protected, but it can also drive water deeper under BGA chips and connectors. For a customer ECU, inspect and dry carefully before dunking.
Council's verdict, ultrasonic only after verified backup and full disassembly. Moisture loves hiding under BGAs.
So ultrasonic will be then, but I presume we're gonna do a full backup first. At least we have the data, so we don't lose anything. Good. So we're gonna open Flex. Let's move the screen. I'm gonna open Flex. I'm gonna connect it to the USB. Perfect. And now we're gonna look EDC17. No update now. EDC17 CP02. CP02 or 04? 04. 04. Audi Q7. Perfect. 3 liter. I'm gonna do a bench read. So we're gonna go. I'm gonna do a bench read. I'm gonna go bring up the manuals. 1, 2, 3, 4, 5, 6, 7 wires. Good. Let's connect them quickly. Let's connect them quickly. Good. So we have positive. Have negative here. We'll need one more big positive. Positive here. One, two, three, 4, 5, 6, and the 8th of here. 1, 2, 3, 4, 6, 8 there. Perfect. And now number 5 and 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and 6. Now number 7, which is this, and number 8, which is this. Perfect. And now we can read it and connect. Let's see. Next one, what it will come? It will be this power supply, and the AI console will be able to control it. Now let's see if the ECU is reading or not. Can't see no signs at the moment. That's very weird. It's correctly. It's correctly done. See if I miss anything. I didn't miss anything. It's number 6. This is number 7. Good. Everything is connected. Let's try one more time. It's drawing about 100 amps, 100 milliamps. which is quite low, to be honest. 200 milliamps. So it looks like we're gonna have a second video. A second video with trying to revive it. Nope, still doesn't want to go communicate. Yes, so we're gonna keep it short for today, as short as possible, because I still got 2 more jobs that I need to attend to after. But what we realized that the ECU was water damage, and we can saw the water inside the ECU, and now we just need to bring it back to life, do like ultrasonic cleaner on it, and find what that missing components was. We have plenty ECUs here, and we can work around what component it was. But up till next one, yeah, what I can say, good luck and have a great day, and I'll see you in the next one. See you later.